Welcome back to the deep dive. I want to start today with a feeling that I think a lot of us have had lately.
Oh, I know the feeling you're talking about.
Right, you're using an AI, you ask it a tricky question, maybe it's a logic puzzle or a really complex piece of code, and it answers just instantly.
Yeah, the cursor just absolutely flies across the screen.
Exactly. And while that speed is, it's impressive, there's a part of you that goes, did you actually think about that?
Right. Or did you just auto-complete the most likely next word?
Because usually when humans solve hard problems, we pause. We stare at the ceiling for a bit. We scribble things on a napkin.
We deliberate. We weigh our options.
We deliberate.
Yeah.
Well, if you look at the news coming out of Google from February 9th to the 15th of this year, 2026, I think we're going to look back at this specific week as the moment the AI actually started staring at the ceiling.
Honestly, that's the perfect way to frame it. The industry is calling it the architectural pivot.
The architectural pivot.
Yeah. For the last few years, we've all been completely obsessed with tokens per second. Speed, basically. But this week, the core metric changed to quality of thought.
And we have a headline number from the sources this week that proves it, 48.4%.
Right. 48.4%.
Now, to the uninitiated, that sounds like a failing grade. If I brought that home on a math test, I would be grounded.
Oh, absolutely.
But this isn't high school history. This is humanity's last exam.
Which, by the way, is just the most dramatic name for a benchmark I've ever heard.
It sounds like a sci-fi movie title.
Yeah.
But give us the context here. Why is a 48% on this specific test stopping researchers in their tracks?
Well, because this test was designed specifically to break AI. It's not checking if the model has memorized all of Wikipedia. It's checking for raw, unassisted reasoning.
So no calculators.
No calculators, no Python interpreters, no Google search. Just the model's brain against the hardest graduate-level problems we could find. Until this week, models were scoring in the single digits or maybe the low teens if they got lucky.
So jumping to 48.4% is...
It's not an iteration, it's a species-level jump.
And the engine behind this jump is really the big story of the week. On February 12th, Google DeepMind announced a massive upgrade to the Gemini models, specifically the DeepThink capability.
Yes, Gemini 3, DeepThink. And the magic here isn't that it knows more facts, it's how it processes them. They've implemented what they call search-based reasoning loops.
Okay, let's unpack that term, search-based reasoning loops.
Yeah.
To me, that sounds like it's just Googling the answer, but you just said it's not using external tools.
Right. It is not searching the web. It's searching its own imagination, essentially.
It's imagination.
Think about how you play chess. You don't just grab a piece and move it. You simulate. You say, if I move here, my opponent moves there, then I take the rook.
You play out the future in your head before you touch the board.
Exactly. You're searching through the space of possible moves. DeepThink generates multiple potential paths to the answer, verifies them against its own internal logic, and effectively debugs its thought process before it ever sends a single word to your screen.
Psychologists call this System 2 thinking, right?
Precisely. System 1 is pure instinct. System 2 is slow calculation. And the results completely validate this approach. We mentioned humanity's last exam, but look at the Erdős AGI-2 benchmark.
Which tests fluid intelligence.
Right, adapting to visual puzzles you have literally never seen before. DeepThink hit 84.6% on that.
And I saw in the release that was verified by the Erdős Prize Foundation, so it's not just Google grading its own homework in a vacuum.
Correct. And for the programmers listening to us today, they posted a score on Codeforces.
Oh, Codeforces. That's like the Olympics for competitive coding.
It is. The model hit an ELO rating of 34555.
I know just enough about competitive coding to know that 3455 is absurd. That's well beyond your standard senior engineer level. That's legendary grandmaster territory.
It really is. It's solving algorithms that stump the top 0.1% of human programmers. But here's the rub. It's not just solving puzzles anymore.
It's moving into real research.
Yeah. DeepMind took this thinking engine and built an autonomous agent on top of it. They called it Aletheia. And on February 12th, they published on the DeepMind blog that they pointed Aletheia at the Erdős conjectures.
The Erdős conjectures, named after Paul Erdős.
These are basically the white whales of mathematics, right?
Exactly. These aren't textbook problems where you can just look up the answer in the back. These are open questions, unsolved frontiers of math.
And what did the agent do?
Aletheia scanned 700 of them from the database. And it didn't just offer helpful suggestions, it cracked 4 of them. It actually proved 4 previously unsolved conjectures.
Completely autonomously, like no human in the loop guiding it.
No human intervention required to generate the proofs. It even wrote the paper. If you go on ArcSAF, there is a publishable paper referenced as Feng 26 regarding eigenweights in arithmetic geometry.
Eigenweights in arithmetic geometry. I won't pretend to know what that means.
Most people don't.
Yeah.
But the key detail here is the author is effectively the AI. That feels like a very significant line to cross. I mean, we are so used to AI aggregating what humans already know. We're not used to AI creating brand new intellectual property.
That's the core takeaway for segment A. We've officially moved from the AI as a library, where you just retrieve information, to the AI as a researcher, where it generates novel IP.
It's the difference between hiring an intern and hiring a colleague.
Exactly.
Now, speaking of colleagues, let's talk about a very different kind of collaboration. One that involves birds and whales.
Oh, Perch 2.0, yes.
Yeah, this dropped on February 9th from Google Research. And I assume the name Perch implies it was built for birds.
It was. It's a foundation model for bioacoustics, trained primarily on bird chirps and terrestrial animals. You know, foxes, dogs, robins, that sort of thing.
So things that make noise in the air.
Right. But researchers had a theory. They thought sound is just data. A spectrogram of a bird chirp has physical patterns.
A visual representation of the audio.
Exactly. So they hypothesized that a spectrogram of a whale song might have similar structural pattern, even if the frequency and the medium are totally different.
So they literally took this bird-watching AI and just threw it in the ocean?
Metaphorically, yes. They tested it on underwater whale vocalizations to see if it could classify them, and it worked beautifully.
That is wild to me, because usually if you want to train a machine learning model on whales, you would need thousands of hours of incredibly expensive underwater recordings.
Millions of dollars in data collection and cleaning. But this proves that transfer learning really works across radically different physical domains, air to water.
So you take a model that learned the grammar of sound from a forest, and you apply it to a coral reef.
Right, without needing a massive new data set. It suggests we don't need a separate, giant brain for every single task. A general perception model can just adapt.
Which is fantastic news for efficiency. But I want to pivot from the abstract, stuff math proofs and whale songs to the concrete. Because most of our listeners aren't solving the arose conjectures today. They're trying to ship code or analyze corporate data.
The Monday morning reality.
Exactly. Let's move to segment B, looking at products and developer platforms. For developers, this new thinking AI shows up in a tool called Conductor.
Right, the Conductor extension for the Gemini CLI.
The big announcement on the Google Developers blog on Feb 13th was the automated review feature. And I think to understand why this matters, you have to understand the sheer anxiety of using AI for coding today.
The trust but verify problem.
Even less than that. Usually it's the copy, paste, and pray method. You ask the chatbot for a Python function, you paste it in your IDE, and you just pray it doesn't break production.
Or introduce a massive security flaw.
Which happens all the time. But Conductor flips that entire dynamic.
It does. It moves agentic development from a trust me model to a verify me model. When the Conductor agent writes code now, it doesn't just hand you a text block, it spins up a sandbox.
Okay, so it builds a safe environment.
Right. It runs the test suites itself, it checks the code against your company's style guide, and crucially, it scans for security issues like hard-coded API keys.
Oh man, LLMs love to hard-code API keys.
They really do. It's a huge security risk. But Conductor flags all of that before the code is finalized.
So by the time the human developer actually reviews the code, the AI has already acted like a junior engineer who aggressively double-checked their own work.
Ideally, it acts like a senior engineer reviewing the junior's work. It closes the loop. It means enterprise teams can actually trust these agents to do the job safely.
Which is huge for enterprise adoption. And speaking of enterprise friction, we also saw a major shift this week in how these agents access real-world data, the Data Commons MCP.
Oh, this is such a sleeper hit.
Right. It sounds so boring. Model Context Protocol hosted service. But reading the developer blog from February 9th, it solves a massive headache.
It really does. Before this week, if you wanted your AI agent to answer questions using authoritative public stats like UN demographics or US Census data, you had to do it all manually.
You had to write a Python script, download the CSV file, clean the data, and then feed it into the model's context window.
Pure friction. But now, Google launched this as a free cloud-hosted MCP service. You just plug it in. Your agent can now speak directly to the massive Data Commons database.
So if I ask my agent, compare the GDP growth of Brazil and India adjusted for inflation over the last decade, It's not going to hallucinate the numbers.
No, it queries the World Bank or the census directly via natural language and pulls the exact stats. It completely removes the firewall friction.
It grounds that incredible reasoning model we talked about earlier in real-world facts, instantly.
Exactly.
Now, grounding the reasoning in the physical world is a perfect segue to my absolute favorite story of the week: snowboarding.
I had a feeling this was going to be your favorite.
I mean, Google Cloud partnering with U.S. Skis and Snowboard to measure rotational magnitude. This sounds like sci-fi sports broadcasting.
It does, but it's really a fascinating physics and computer vision story. Usually, to analyze the precise physics of an athlete's jump, they have to wear a motion capture suit.
Right. Sensors on the board, sensors on the helmet.
Which is incredibly intrusive. Athletes hate it. So on Feb 12th, Google Cloud revealed they use Gemini and DeepMind computer vision to calculate all of this entirely from standard video feeds. No sensors required.
But they didn't just measure how high the snowboarder went, right? They discovered something called the efficiency gap.
Yeah. The AI analyzed the physics using quaternions.
Quaternions. We're throwing a lot of heavy math around today.
I know. Simply put, quaternions are a complex type of 4D math used to calculate 3D rotation without getting errors. The AI used this math to look at freestyle tricks, and it found that the best athletes use a technique called corking.
Which is when you tilt your axis off-center during a spin. I always thought corking was just for style, to look cool for the judges.
That is what everybody thought. But the AI proved that corking is actually a diagonal shortcut through three-dimensional space.
A shortcut.
Yeah. It allows the athlete to complete a high-difficulty trick with less physical rotation than a straight, flat spin.
That is fascinating. The AI found a geometric hack in the sport that humans were doing intuitively, but we couldn't mathematically explain until now.
It's multimodal AI applying complex physics to optimize real-world human performance. It's brilliant. But, and there is always a but on this show.
Here comes the reality check. Segment C infrastructure.
Right. All of this. Simulating 3D snowboarding physics, running System 2 reasoning loops, solving the Erdős conjectures. It is incredibly computationally expensive.
It eats compute for breakfast.
We are officially moving from a world where inference is cheap to a world where inference is the massive bottleneck. Which brings us to the hardware unveiled this week, Ironwood.
Ironwood, Google's 7th generation TPU.
Yes. And while the tech press focused a lot on the liquid cooling or the fact that it scales to clusters of 9,216 chips, the architectural strategy is what really matters. Ironwood is optimized specifically for inference.
Why make that distinction so strongly? Why not focus on training?
Because of everything we just talked about. Training a model is like the med school phase. You teach it everything it needs to know over a few months, but inference is the surgery phase. It's the model actually doing the job every single second of every day.
And now that the surgery involves deep thinking, checking its own code, and running physics simulations, it takes exponentially more energy.
Exactly. The model isn't just spitting out text anymore. It's running complex simulations in its head. So Google needs silicon that is purpose-built for the day job of AI. They have to run these reasoning loops at a global scale without bankrupting the company on power bills.
And the scale they're talking about is almost hard to wrap your head around. There were leaked internal memos this week, reported by TechCrunch and Ars Technica, regarding an internal mandate.
Ah, yes, the compute mandate. The goal is to double compute capacity every 6 months.
Wait, Moore's Law is doubling every 18 to 24 months. They want to double every 6 months.
That is the internal target. They are aiming for a 1,000x increase in compute capacity over the next 5 years.
1,000 times more compute in 5 years. Well, that explains the liquid cooling on the Ironwood chips. You're practically building a fusion reactor at that point just to keep it from melting.
You're building the physical infrastructure for a synthetic global brain. If you want a model that can sit and think for 5 minutes before answering a question, you need 1,000 times the compute you have today. It's just math.
But as we build this massive capacity and as these models get smarter and more capable, we aren't the only ones using them.
No, we are not. Which brings us to segment D, safety and security.
On Feb 13th, the Google Cloud Threat Intelligence Group GTIG dropped a report detailing adversarial AI use. And it's pretty sobering. They highlighted a massive rise in something called distillation attacks.
Distillation. It sounds completely harmless, like making whiskey, but it's basically intellectual property theft. Think of it like corporate espionage, but for an AI's brain.
How does that actually work?
Hackers automate thousands of complex queries to a high-end model like Gemini DeepThink. They record the brilliant, reasoned answers, and then they use that data to train their own, smaller, unregulated models.
So they are effectively stealing the intelligence without paying the millions of dollars for their original training.
Exactly. They extract the teacher's knowledge to build a student model. And the danger is that student model has no safety filters. It's a way for bad actors to bypass all the ethical guardrails that companies spend years building.
And that wasn't the only threat in the report. They also discovered a new malware family, HonestQ.
HonestQ sounds so trustworthy, doesn't it?
It sounds like a generic payroll app.
It is deceptively named. This malware was actively using Gemini's API to generate C# payloads in memory to evade detection.
Okay, in memory, meaning it doesn't actually touch the computer's hard drive.
Right. Traditional antivirus software works by scanning the files saved on your disk, but this malware lives entirely in the fleeting RAM of the machine. The AI generates the malicious code on the fly, executes it in the memory, and then it just vanishes.
It's a ghost attack.
It is. It shows that cybersecurity is no longer just about building higher firewalls to keep the hackers out. It's about preventing the AI itself from being weaponized or cloned by adversaries.
It feels like we are walking a very delicate tightrope right now. On one hand, we have Aletheia expanding the actual frontiers of human mathematics, and on the other, we have HonestQE writing invisible ghost malware on the fly.
That is the duality of this architectural pivot, and it's exactly why you saw Google pushing so hard on the Safer Internet Day initiatives this week on Feb 10th.
Right, the new default protections for teens.
Yeah, things like the school time lockouts and stricter content boundaries on YouTube. They're trying to balance this hyper-accelerated AI timeline with the necessary social guardrails for younger, vulnerable users. You're building guardrails on a highway where the cars just suddenly started going 1,000 miles an hour.
It's a lot to process.
Yeah.
Before we close out today, I wanted to touch on one final story in segment E, because we talk a lot about enterprise AI, and sometimes it just feels theoretical. It's like a buzzword. But this week, Wesfarmers went all in.
Wesfarmers, the massive Australian retail giant.
If you're listening in Australia, you know exactly who they are. Kmart, Bunnings, Officeworks.
Right. They announced a massive partnership with Google Cloud on Feb 13th to deploy Gemini Enterprise across their entire workforce.
And their workforce is 118,000 employees. That is the size of a small city.
It really is. And the crucial detail here is they aren't just giving their staff a chatbot to write polite customer service emails. They are deploying agentic AI to handle deep operational workflows, inventory, logistics, supply chain routing.
So this isn't a pilot program.
No, this is full-scale deployment. It's the strongest signal yet that the experimentation phase of AI is over for retail. Highly profitable, traditional businesses are moving firmly into the deployment phase.
Wow. So let's recap this week. Between February 9th and February 15th, we saw an AI score 48% on humanity's hardest test by using deep reasoning loops. We saw autonomous agents solving unsolved math proofs and strictly reviewing their own enterprise code. We saw infrastructure scaling toward a 1,000x increase with liquid-cooled chips. And we saw massive corporate deployments alongside new, highly sophisticated cybersecurity threats.
It is an absolute whirlwind of a week. But honestly, there is one final piece of news from this week, internal news from Google, that I think sums up the stakes better than any benchmark score ever could.
You're talking about the voluntary exit program.
Yes, a leaked memo went out to Google's global business organization this week, and it was incredibly blunt. It stated that the AI transformation is happening right now, and it told employees, you must be all in on this shift.
And if they weren't all in,
They were offered a severance package to leave.
man, get on the train or get off the tracks.
It is a harsh message, but it's a deeply clarifying one. And it's not just about Google's internal culture. It is a loud signal to the entire global labor market. The tools we talked about today, Ironwood, DeepThink, Aletheia, they are scaling exponentially. And the organizations building them are radically restructuring themselves to match that exact speed.
And that leaves us with the big provocative question for you, the listener, to mull over this week.
Exactly. If the technology has officially moved from chatting to reasoning, if the AI is ready to stop playing around and actually start doing the deep work, are you?
If the hardware is scaling 1,000 times over the next 5 years, are your personal workflows ready to move from simply chatting with an AI to fully delegating complex tasks to a colleague that thinks 1,000 times faster than you?
That is the real question.
Something to seriously chew on this week. Thank you so much for joining us for this deep dive into the architectural pivot. We will see you next time.
Stay curious, everyone.